In a time when environmental awareness and technological advancement are shaping the future of transportation, one name shines brightly in the world of electric vehicles. Maxwell Chikumbuso, a Zimbabwean inventor known for his groundbreaking innovations in energy systems, has developed a self-sustaining electric vehicle that has the potential to challenge the very core of how we understand energy consumption and mobility. If Chikumbuso's self-powered EV successfully completes its ambitious 7,500 kilometers journey from Zimbabwe to Cairo, it will mark a significant milestone in the pursuit of independent and sustainable energy. But what happens after such an incredible achievement? This video delves into Maxwell Chikumbuso's revolutionary innovation, its potential to disrupt the automotive industry, and the challenges that may emerge as this technology paves the way for the future of energy-efficient transportation. It will explore the technical intricacies behind how a self-powered EV can travel such an astonishing distance without external charging, the implications for the automotive world, and the broader shift towards sustainable mobility. Chikumbuso's breakthrough isn't just about another electric vehicle, it represents a completely new way of harnessing and utilizing energy in transportation. While conventional EVs rely on external charging points, typically powered by grids that still largely depend on fossil fuels, his self-sustaining electric vehicle generates its own power. This design allows it to function continuously without the need for repeated charging stops. The core of this innovation is an advanced energy conversion system, a technology that redefines traditional approaches to power generation in vehicles. At the heart of this self-powered vehicle is a device that integrates advanced energy harvesting and conversion techniques. The vehicle is equipped with a system that taps into surrounding electromagnetic fields, converting these fields into usable electricity. This revolutionary concept challenges the long-standing reliance on large batteries and external charging points, which have traditionally been seen as essential for electric vehicle operation. Unlike standard electric cars that deplete battery power and need to recharge, Chikumbuso's vehicle is designed to continuously generate electricity through its propulsion system. This system employs an energy-efficient motor based on electromagnetic induction principles, allowing the vehicle to generate and utilize power simultaneously. In essence, the car powers itself as it moves, creating a closed-loop energy cycle. This enables it to function indefinitely without ever needing to connect to an external charging source. This self-sufficient design is not just a major technological advancement, it challenges the very infrastructure of the modern energy system. If successful, it could revolutionize the automotive industry in ways previously thought impossible. To demonstrate the viability of this groundbreaking technology, Chikumbuso has planned an ambitious 7,500 kilometers test drive from Zimbabwe to Cairo. This journey, which will cross multiple countries and diverse terrains, aims to prove that the vehicle can sustain power generation under real-world conditions over long distances. Successfully completing the journey would not only validate the technology but also serve as a critical real-world proof of concept for self-powered electric vehicles. One of the biggest questions surrounding this concept is how a vehicle can travel such vast distances without requiring a recharge. The answer lies in the principles of perpetual motion and energy conservation. In Chikumbuso's design, the vehicle generates power from the surrounding electromagnetic fields while also utilizing regenerative braking systems. Together, these features allow the car to maintain an energy balance sufficient for long-distance travel. The self-powered EV integrates a range of energy-efficient technologies that harness atmospheric energy, gravitational forces, and mechanical energy conversion. This forms a fully closed-loop energy system that sustains itself as the vehicle operates. The concept of free energy devices and perpetual motion machines has been around for centuries, but Chikumbuso's breakthrough is in successfully applying these principles in a way that is practical, scalable, and capable of meeting the energy demands of a moving vehicle. The test drive will serve as a crucial experiment to determine if this technology can function reliably under real-world conditions. While the idea of a self-powered car is undeniably fascinating, it raises important questions about how such a system handles external variables. For example, how does the vehicle adapt to changing road conditions, extreme weather variations, or the increased power demands required for uphill driving and high-speed performance? These are challenges that Chikumbuso and his team will need to refine as they move forward with their technology. If successfully developed and adopted on a large scale, this self-sustaining technology could have a profound impact on the automotive industry and society as a whole. One of the most significant benefits would be reducing the dependency on fossil fuels. A self-powered vehicle would eliminate the need for traditional charging infrastructure, much of which is still powered by non-renewable energy sources. By creating a vehicle that generates its own electricity, Chikumbuso's innovation presents a possible solution to the environmental challenges associated with carbon emissions and fossil fuel consumption. This could make a substantial contribution to global efforts to combat climate change. Additionally, the widespread adoption of self-powered vehicles could revolutionize the current EV charging infrastructure. One of the primary challenges of electric vehicle expansion today is the need for an extensive and accessible charging network. If EVs become self-sufficient in power generation, charging stations could become obsolete, eliminating one of the major obstacles to EV adoption. Drivers would no longer need to worry about charging locations, making long-distance travel more convenient and efficient. Another major advantage of this self-powered technology is cost reduction. Traditional electric vehicles rely on expensive battery packs, which significantly contribute to the overall cost of manufacturing and maintenance. A self-powered EV that reduces dependency on large batteries could lower production costs over time, making electric vehicles more affordable for a wider range of consumers. In the long run, this could accelerate the transition toward a sustainable transportation system by increasing accessibility and affordability. Chikumbuso's work could also inspire further advancements in energy technology. If his concept proves successful, it could open the door for new methods of energy generation and storage, potentially influencing developments in solar, wind, and kinetic energy technologies. The automotive industry could shift toward a new era where vehicles are not just energy efficient but entirely self-sufficient, challenging current assumptions about transportation and energy consumption. However, despite its exciting potential, Chikumbuso and his team must overcome several significant challenges before this technology becomes mainstream. One of the biggest hurdles is proving that the system functions reliably under real-world conditions. The 7,500 kilometers journey will be a critical test, exposing the vehicle to a wide range of environmental factors such as unpredictable weather, rough terrain, and varying traffic patterns. Even minor inconsistencies in energy generation could cast doubt on the viability of the technology. Another major challenge is scalability. Even if the system works on a single vehicle, mass production presents its own set of obstacles. Ensuring that the energy system integrates seamlessly with other mechanical components such as the motor and transmission will require extensive refinement and testing. Additionally, regulatory frameworks will need to adapt to accommodate self-powered vehicles. Governments and transportation authorities may need to update laws and vehicle safety standards to align with this new technology, which could be a time-consuming process. Public perception will also play a crucial role in determining whether self-powered EVs gain mainstream acceptance. Consumers need to trust that such a vehicle is reliable, safe, and truly self-sustaining. Since this represents a radical shift in how people perceive energy and transportation, extensive education and marketing efforts will be necessary to overcome skepticism and build confidence in the technology. Maxwell Chikumbuso's self-powered electric vehicle could represent the next major evolution in sustainable transportation, where energy independence, environmental responsibility, and groundbreaking technology converge. If the 7,500 kilometers test drive from Zimbabwe to Cairo is successful, it could be a defining moment in the future of electric vehicles. As this technology matures and its challenges are addressed, the automotive industry may see a shift toward vehicles that are not just energy efficient, but completely independent of conventional charging systems. This self-powered EV is not just a glimpse into the future of transportation, it is a bold challenge to reimagine how we approach energy and sustainability in the automotive world. If the journey to Cairo proves successful, the path toward a cleaner, self-sufficient future could be much closer than we ever imagined.